Greetings, everyone. In this short clip, we are going to look at the chapter 13 problem, okay, that I've given earlier, and we will look at the solution. Yeah. All right. Let's continue. Right. This is the information about the question. Yeah. It starts with the table. The table below provides the possible returns for the three different assets. Okay, asset X, Y, and Z. Yeah, under four different states of the economy. Yeah, in 2024, these are the four states: bust, static, growth, and boom. Yeah. So note that this table is given in this manner. Yeah, this particular manner. But students need to remember that sometimes the tables can be reversed or inversed. Yeah? For example, assets can be here and the economic states can be given here. Okay, column wise, state can be column wise and assets can be row wise. Yeah, here the state is row and the assets are columns, in different columns. Okay, so please be careful, yeah, because if you expect it to be the same, yeah, in all questions, it may be different, right? Therefore, you need to be careful, yeah. So most students interpreted the table accurately, but some students misread the table. Yeah, so please be careful in reading the table. Yeah, and the question also says if you invest in assets X, Y, and Z respectively, 50%, 30%, and 20% of your investment funds. Yeah, and this information is reflected here. This is 50%. Is 30% for asset Y and 20% for asset X. Sorry, Z. Yeah, asset Y is 50%. Yeah, asset X is 50% here. Okay, so this is how you should interpret the table. Okay, and note this. Yeah, here, how do you read this table? Let's take this example here, 9%. What does that mean? It means that, okay, given the economic state is growth, okay, the probability of growth is 0.35 or 35%, okay. Asset Y, which makes 30% of the portfolio, yeah, of your portfolio, 30% of your portfolio, will have a return of 9% under this condition. Okay, so that's how you should interpret the table. Okay, you should interpret all the other cells in the same manner. Okay, all right. If you have any questions about this, any doubts, please raise your doubts or questions in the comments to this clip. Yeah, let's move on to the next slide. Okay, these are the questions. Yeah, there are 6 questions in this problem, and these are enumerated here. Yeah, very quickly, let's go through the questions. The first one is calculate the possible returns of your investment portfolio under each of the 4 economic states in 2024. Yeah. Therefore, the question is about possible returns, but these possible returns will be different for 4 different economic states. Okay, so that is the first question. The second question is calculate the expected return of your investment portfolio in 2024. Note this, yeah, this is expected return. The previous question was on possible returns, yeah, and there are 4 possible returns because there are 4 economic states. Here there is only one, yeah, expected return for the investment portfolio. Okay. Now for the third question, question C, calculate the standard deviation of returns for your investment portfolio in 2024. Yeah. Question 2 was about expected return. Question 3 is about standard deviation of returns. Okay, this is about risk. Okay, standard deviation is a measure of risk. All right, question D, the fourth question is about the beta. Yeah, if the expected return of the market portfolio is 8% and the risk-free rate is 2%, what ought to be the beta of your portfolio, assuming that that your portfolio is fairly priced, and that means also that all the stocks that make up your portfolio are fairly priced. Okay, so here the question is about the beta. Yeah, and then the fifth question is if your beta is 0.4 Is it fairly priced, underpriced, or overpriced? Explain your answer. Yeah, so that's the fifth question. And the final and sixth question will be, how will your portfolio price change? Will it rise, fall, or remain unchanged? And given this, yeah, if your portfolio beta is 0.4, will your portfolio price increase, decrease, or remain unchanged? Yeah, that's the sixth and final question. Yeah. All right. Let's look at the answer for each of these six questions in turn. Yeah. Let's move on to the next slide. Right. In this slide, we are going to answer the first question. Yeah, the first question was about finding out the possible portfolio returns under each of the four economic states. Okay, let's start with the first one. Yeah, the first one is bust. So if the economic condition is, or the economic state is bust, what would be the possible portfolio return? Okay, so for that we need to create a new column, yeah, for portfolio. Right, and the working is shown here, the calculation is shown here, yeah. So the weight for asset X in the portfolio is 0.5, okay, because 50% of your portfolio will be made up of asset X. And asset X return will be negative 8%, yeah, under bust. So it's 0.5 multiplied by negative 8 plus 0.3 here multiplied by negative 11%. Plus 0.2 multiplied by 10% here, yeah? Then you add all of this, you get negative 5.3. That's reflected here, all right? So you do the same for the other conditions, yeah? Like static, growth, and boom, yeah? And this is what you would get. For static, it will be this, okay? 0.5 multiplied by 2%, 0.3 multiplied by 4%, 0.2 multiplied by 6%, and you add them all up, you get 3.4% reflected here, right? For growth, it'll be 0.5 multiplied by 12%, 0.3 multiplied by 9%, 0.2 multiplied by 1%. You add them all, you get 8.9%. Okay. Likewise, for the final state, boom, 0.5 multiplied by 22%, 0.3 multiplied by 24%, 0.2 multiplied by negative 4%, you get 17.4%. So that's how you get the answer for the first question. Okay, let's move on to the next question in the next slide. Right, in this next question, it is about the portfolio's expected return. Remember, for expected return, we need only two things. Yeah, one is the possible return for the portfolio, and we need the probability. Okay, probability of each condition. Yeah, the possible returns under each condition and the probability for each condition, yeah, or each state. Okay, once you've got that, then we can calculate the expected return. Yeah, so the expected return is 0.15. We can ignore this, yeah, all these are not necessary. We need 0.15 multiplied by negative 5.3% plus 0.45 multiplied by 3.4%, 0.35 multiplied by 8.9%, and finally 0.05 multiplied by 17.4%. That will be your expected return for the portfolio, 4.72, yeah. So for this question, okay, we will use the probability. We don't use the weight. Yeah. For the previous question, we will be using the weight, or we have used the weight and not the probability. Okay, so please be careful. Yeah, which one is used when? Yeah. For expected return, we use probability. For possible return for the portfolio, we need to use the weight. Okay. All right. Let's move on to the next question. If you have any questions about this, if you have any doubts, please raise your question in the comments to this clip. Yeah, thank you. Let's move on to the next question. Right, in this question, okay, question C, we are asked to calculate the portfolio standard deviation of returns. Yeah. But in order to calculate the standard deviation of returns, first we must calculate the portfolio variance of returns. Yeah, so we'll do that first. But remember, for variance, we need three pieces of information. Yeah? First, we need the possible returns for the portfolio, because it's about the portfolio variance. Yeah? We need the possible return for the portfolio. Then we need, second, the expected return of the portfolio. Then third, we need the probability, yeah, of each condition. Okay, each condition or each possibility. Yeah, so we have these three, and we can calculate the portfolio variance. Yeah. Now the portfolio variance is calculated this way. We take negative 5.3 here, this negative 5.3 minus the expected return. This is the first possible return, minus the expected return 4.72. You square that, then you multiply with the probability of the first condition, yeah, which is bust, 0.15, right? You repeat the same for the other conditions, yeah. 3.4, the possible return under static, minus 4.72, the expected return. You square that, then you multiply with the probability under static, yeah, which is 0.45. Then 8.9% minus 4.72, you square that, then you multiply with 0.35. Then finally 17.4% minus 4.72%, you square that, then you multiply with 0.05. Yeah, and you add them all up, you get 29.9986 percentage square. Note this, yeah. Here I have not changed any of the numbers. Okay, I have not converted them to decimal. I've just used negative 5.3 minus 4.72, and then I square that. Yeah, I just ignore the percentage. Yeah, for the moment. Yeah, because if it's a percentage you minus, it's still percentage. Then you square the percentage, it becomes percentage squared. Okay, so rather than changing it to decimal, because changing to decimal you will have to deal with decimal points. Yeah, if you get it wrong, okay, because you have many zeros, 0.00 and so on, if you get 1 0 wrong, okay, you move the decimal by one point, then the whole calculation will go wrong. Yeah, so there are greater chances of error, right? Therefore it is best to just retain the percentage symbol. Yeah, just ignore that for the moment. You square that, it becomes percentage squared. Okay, so this is better solved this way. Yeah, so it's 29.9986%. Yeah, when you add all the weighted squared deviation, yeah, weighted squared deviation, then it becomes 29.9986 percentage square. This is the variance, yeah, variance of the portfolio, variance of returns, yeah, for the portfolio. If you want the standard deviation, then you just take the square root of the variance. Okay, you take the square root of this variance. Square root of percentage square is percent, yeah. So therefore, square root of 29.9986 is 5.4771, yeah, rounded to 4 decimal points. So this is the answer for question C. Yeah, if you have any questions about this, any doubts, please raise that in the comment section to this clip. Yeah, thank you. Let's move on to the next slide. Now, let's look at the answer to the fourth question, question D. Yeah, you need to calculate the portfolio beta given these three pieces of information. Yeah, you are given that the market portfolio expected return is 8%, the risk-free rate is 2%, and all component stocks of the portfolio are fairly priced. Now, based on this, you can infer that if all the component stocks are fairly priced, then the portfolio must also be fairly priced. Yeah. So if the portfolio is also fairly priced, then the portfolio's reward to risk ratio must be the same as that of the market. Okay, so this is an important inference. Yeah, the reward to risk ratio for the portfolio must be the same as the reward to risk ratio of the market. Therefore, we know that from our earlier calculation, we know that the portfolio expected return is 4.72%. Yeah, we have calculated this earlier. Yeah, for question B. Yeah, so based on that, we can equate, yeah, the two reward to risk ratio for the portfolio as well as the market. Yeah. So on the left, you have the market. 8% is the market expected return from here. Minus 2%, the risk-free rate, divided by the systematic risk for the market is always beta equals to 1. Yeah. Right. That is the reward to risk ratio of the market must be equal to the reward to risk ratio of the portfolio, yeah, which is 4.72 minus 2 divided by the portfolio beta. We want to solve for the portfolio beta here. Yeah. Therefore, the portfolio beta, if you bring this portfolio beta to the left hand side and you bring this 8 minus 2% to the right hand side at the bottom, then it becomes 4.72 minus 2 divided by 8% minus 2%. Yeah? Therefore, it becomes this 0.4533. Okay, that's the beta of the portfolio. That's how you should solve this problem. Yeah. If you have any questions about this, please raise that in the comments. Yeah, let's move on to the next slide. Right, we move on to the next question. We try and answer the fifth question. Yeah, the question is whether the portfolio is fairly priced. Okay, now if the portfolio beta is given as 0.4, okay, and you know that the portfolio required return, if it is fairly priced based on CAPM, yeah, this is a formula for CAPM, 2% is the risk-free rate plus 8% the market return minus 2% the risk-free rate multiplied by the beta for the portfolio. If the beta is 0.4, yeah, then it will become 4.4%. This is the portfolio required return. Okay, note this. Yeah? This is the required return based on CAPM. But the expected return is 4.72. Yeah, we have seen that. Yeah, we have calculated this earlier. Based on the expected return is 4.72, but the required return based on CAPM is 4.4. Now, since the expected return is higher than the required return, the portfolio must be underpriced. Okay, why is it underpriced? Remember, yeah, the expected return is too high. Okay, high compared to the what is suggested by CAPM. Yeah? CAPM proposes that or tells you that the portfolio required return is 4.4%, yeah, or should be 4.4%, but your estimate is the portfolio expected return is 4.72, which is higher. Yeah. Now the expected return is higher because the price is lower. Remember always, yeah, the relationship between price and return, yeah, the expected return. The expected return is high when the price is low. Yeah. When the price is high, the expected return will be low. Yeah. Therefore, here when the expected return is higher than the required return, it implies that the price of the portfolio is less, yeah, than the value of the portfolio. That is why it's underpriced. Is that clear? Okay, yeah. Please think about that. Yeah? If you are not clear, think about the argument step by step. Yeah, then it will become clearer. Okay. All right. That's the answer for the fifth question. Let's move on to the final question. Yeah, final sixth question. Now we come to the final question. Yeah. All right, so the final question is about portfolio price change. Yeah, if the portfolio is underpriced, like we found out in the previous question, what will happen to the portfolio price? Okay, so that's the question that we need to answer. Yeah, since the portfolio is underpriced, many investors will buy the portfolio or its component stocks in the portfolio. Yeah. And this will raise the portfolio's price, also the component stocks price. Yeah. So when this happens, this will reduce the portfolio's expected return. Higher the price, lower the expected return. Yeah, that's a relationship. Okay. Now, when the expected return becomes lower, it will become equal to the required return based on the CAPM. Yeah. So when these two are equal, expected return is equal to the required return, then there would be equilibrium. Okay, so that's the answer for the final question, yeah, the sixth question for this problem. Okay, with that, we finish this clip. If you have any question, please raise this in the comment section. I will try and address that there. Yeah, good luck for your final exam. Okay, bye bye now.